Hey guys, welcome back to Mr. Chen class. Today we're going to go over two questions we use, guys. So the first one is going to be involving titration questions, which is acid-based titrations, and the type we're going to be doing is the percentage of purities. And the second one is going to be the involving using rice table. The one I chose is from the mid-year exam. Okay, so but both questions we have to involving using sig phase, so that is very important. Okay, so let's read the question first. A 0.3470 gram samples of impure NaHSO3 is dissolved in water and titrated with a 0.1481 m's, which is concentrations of NaOH solution. If 20.26 milliliters of standard solution is required, calculate the percentage purities of NaHSO3 sample. Okay, so how can we calculate that? Well, you have to be familiar with the percentage of purity formula, which is I already written on the about the page, which is the real concentration divided by the expected concentration times 100%. In this case, we're going to find the NaHSO3, which is this two concentration is going to relate to NaHSO3. But however, some questions is not going to we're not going to. It's hard to find the concentrations. It's better easy to find the mole ratios. I mean, for the mole. So using the actual mole to divide by the expected mole and times 100% is also get the same answer. Okay, let's go over that. So the first step we're going to do is by converting this 22.26 milliliters to liters and times the concentration, then it's better. It's more easy for us to calculate the real mole for the later time. Okay, so we're converting 20.26 milliliter and divide that by 1000 because 1 liter is equal 1000 milliliters. Divide by 1000, we get 0.02026 liters. Okay, so if we get the liters out, we're going to times this using this liters number and going to times the concentrations, which is 0.1481. If we times the 0.1481 and also times the liters, and we get 3.000 and 506 times 10 to the negative 3. Okay, but we also need to care about sig phase. Does it have full sig phase in here and also the false sig phase in here? Why so? Because according to rule number 3, the leading zero are not significant, so we ignore the leading zero and we calculate this answer, which means that we have keeping in full sig phase. So we put a small underline here for reminding us, oh, this is the full sig phase. But why I do so? Because I never round up the answer until you to the in the ending steps. So we also keep it like that. Okay. But another thing we have to explain for you guys is concentration times the liters is equals mole. But why? Okay, concentration is mole per liters. And we're going to times by liters. So these 2 liters cancel each other, which means it's equal mole. Okay, let's keep going. Okay, so we calculate out the pure one. We calculate the impure, which is by using this gram, like 0.3470 grams, so it's mass, and we use mass to divide by the molar mass, which get us the mole. Why so? So mass, because mass is gram, and divide by molar mass is gram per mole, and so we divide them, which means it's going to flip them. These two cancel to each other, and is equal mole. Okay. So now we're going to using the 0.3470 grams to divide by the molar mass, which is going to be Na. Na is going to be 23.0. The next thing is going to be hydrogens. Hydrogen is going to be 1, and sulfur is going to be 32.1, and oxygen is going to be 16 times 3. Okay. Now, according to the rules, multiplication and also division have to be go first before the subtraction and addition. So which means 16.0 times 3 we have to calculate that first. So 16.0 and times 3 is equal 48, and because this one is a 3 sig phase, this one is 1 sig phase, we have to round up 1 sig phase, but never round up, just put the underline, I mean. Okay, so we should put a bracket there in case we forgot to add them up. Now we add them up first. So we add them up: 23.0 plus 1 and plus 32.1 and plus 48. Remember, 48 is have underline, so the vertical line have to be drawing like here, and which is round up into you know, like 2 sig phase in this one. But you know what, addition, you know, the subtraction is never talk about sig phase, talk about decimal. Okay. So now we put underline around 0. I mean under the zeros, and we minus that is 2 sig phase in here. Okay, using the 0.347 grams to divide that by 104.1, and so gram divided by the molar mass, then we calculate the mole out, which is going to be 3.333, so it's infinity 3 times 10 to the negative 3 mole. Okay, this one is actually impure, which is expected mole. And however, we have to also care about sig phase again. They have 4 sig phase in here, and they have 2 sig phase in here, so the answer have to be 2 sig phase. Okay, now according to our formula, mole, that one, we have to be using the mole, actual mole, to divide by the expected mole and times 100%, which we're going to do. Actual mole is going to be that guy. So it's you just copy the entire stuff in here, and also the expected mole is going to be this guy, 3.33 and times 10 to the negative 3. So we put the entire thing in here. Mole divided by mole 2 cancels out, and we have to calculate about sig phase again. There are 4 sig phase in here because there are 4 sig phase in there, and they have 2 sig phase in this guy. So we have 2 sig phase. So the answer have to be kept in 2 sig phase. So you know the answer have to be kept in 2 sig phase, which means time 100%. 100% we don't care about the sig phase about 100%. So it's going to be, the answer is going to be 90%. Yep, that is the end of this video. Hope this helped. Thank you so much. See you next time.